Hello everyone, welcome to today's lesson on linear systems. Alright, or more specifically, solving linear systems by graphing. Alright, so linear systems is a new concept. Right, this is when we are solving for multiple equations at once. Alright, we know what a linear equation is, right? That's the equations that we've been working with for the past how many months? Right, so a system of linear equations is when we have multiple of them at once we gotta solve. Okay, so for example, what does that mean? Right, let's say we have two linear equations here, right? So two lines. And now, is this singular point a solution to the system of equations? So in other words, right, when x is 4 and when y is -1, right, does this solution here fit into both of those equations? Okay, let's check it out. So our first one here, if we plug in the 4 and plug in the y, right, we got 11. That's great. Right, and then for the second equation, plug in the x, plug in the y, which is 6. That's also great. Right, so this right here is then a solution to the system. Right, so again, system is just literally two equations at once. And now a single solution has to fit for both equations. Okay, so of course you can guess every single point in existence, right? You can say, oh, if x is 1, y is 1. X is 1, y is 2. X is 1, y is 3. Of course, that takes forever. So a quick way to go about finding the x and y, right, is by graphing them out. Right, so we have two equations here. Right, to graph it out, of course, it's usually the easiest to put them into slope-intercept form. Right, so first, right, let's get the graph lines here. Actually, before doing anything else, what the? Right, so of course, we can use the slope-intercept form, like convert into the slope-intercept form, and then graph it out. Right, however, if we remember, we got three different forms, right? Slope-intercept, general, and slope point, slope point. Yeah, that one. We got three forms to work with. Right, but the easiest to actually graph with is the general form, which luckily is here. Right, because with the general form, we can easily find the x-intercept and the y-intercept. And that's literally the 2 points we need to connect the line. Alright, so let's take, don't worry, start with the second one first. Let's take this first one. Oops, wrong color. Oh, come on. Alright, so let's take this first equation here. Alright, let's graph it out. Right, let's find the 2 points. The x-intercept is when x-intercept is when y is 0. Right, so that's when x is -4. Right, or more specifically, -4 when x is -4, y is 0. Y-intercept, right, is when x is 0. Right, and we can see here, we can divide both sides by 2. So when x is 0, y must be -2. That's our first line. Oops. So our x-intercept is at -4. Wait. Yeah, -4. Right, y-intercept is at -2. Okay, that's our first line right here. Right. In this case, we're actually gonna to stretch it all the way out. Right, and you'll see why we stretch it all the way out for the whole graph. Okay. Now let's find the other one. That one's a lot easier. X-intercept, again, is 1, y is 0. So x, as we can see here, is just 5. So x is 5, y is 0. Y-intercept, when x is 0. So also, when x is 0, y is 5. Why did I put plus? That would be too easy, right? Minus, minus, minus. So y here is actually x is 0, y is -5. Okay, so x-intercept is 5. Is that 5? 1, 2, 3, 4, 5. Yep. 2, 3, 4, 5. 5 and negative 5. Okay. And then we grab this guy out. Okay. So now this point right here must be on both lines. So in order to find out the single point that fits into both of those equations, we can just see where they intersect, right? Because the point where they intersect, which is right here, right? This point is on both graphs. So that's how we can solve a system of linear equations. This point here is of course 2 comma negative 3. Right, so when x is 2, y is negative 3, right, this will fit both graphs. Right, we can plug it in just to double check, right? When x is 2, y is negative 3. Let's see. 2 plus 2 times negative 3, right? That is indeed negative 4. And then 2 minus negative 3, that's also 5, right? We can always double check. So that's why we want to draw out the entire line on this graph, right? Because again, we want to make sure that it intersects. Okay, but sometimes it's not always nice and easy. Let's take this one here. Okay, let's see. X-intercept is, that's when that's a 0. So that's when x is 3 over 2, y is 0. Right, because we just divide 2 from both sides. Y-intercept is when x is 0. That one's a lot easier to calculate. X is 0, y is negative 1. Right? Divide both sides by negative 3. Okay, the other line. X-intercept and y is 0. Luckily, again, easy math. Divide both sides by negative 2. 6 divided by negative 2 is negative 3. Y-intercept is when x is 0. Okay, even easier math because it's got no negatives, right? Just divide both sides by 3. 0, comma 2. Whoopsie. Okay. We got those two guys here. Okay, so first line, x-intercept 1.5, 3 over 2, right? Y-intercept negative 1. So it's around here-ish, here-ish. Second line, negative 3 x-intercept, 2 y-intercept. Negative 3, 2. Right, so you might notice something here, right? Those two lines are parallel. Right, that's not good, right? Both of those lines are parallel. Right, and because those two lines don't intersect at all, right, then we have no solution. Right, no solution. Right, because if they don't intersect, then there's no such point where x and y applies to both equations, right? There's no point where it's on both lines at the same time. Okay, you can probably see where this is going. What about our last scenario here? Right, if they're parallel, there's no solution. But we got another scenario to look at. So what happens when we graph those two? Shouldn't spoil it right away. Math is mystery, isn't that fun? X-intercept is when y is 0. Solving for x, that's just 2, right? Divide both sides by 2. Y-intercept when x is 0. Easy math, right? Just divide both sides by negative 1, so that's negative 4. Okay, other line. when y is 0. Right, divide both sides by -4. That says 2. Y-intercept when x is 0. Okay. Divide both sides by 2. Uh-oh, what do we have here? 0, -4. Right, look at that. They both have the exact same x and y intercepts. Right? 2 and -4. Right? This is for both lines here. So if we draw this line out, we don't really need to at this point, right? But if we are to draw this line out, we can see here that both of those lines are literally the exact same line. Which means that every single point on this line is a solution, right? Because it doesn't matter where the point is, right? As long as this point is on the graph, it hits both of those lines, right? Because both lines are literally the same line. So when this happens, we call this infinite solutions. Right? So this will always happen with systems of linear equations, right? The three scenarios. We either have one solution, here, which you have to solve, no solution, because the lines are parallel, and infinite solutions when both lines are the exact same. Okay, so we can see here in this little chart, you can see my completely straight line. I rushed on this one, whoopsie. When the lines intersect, right, the slopes must be different. Right, the only time where they can intersect is when if the slopes are slightly different, then they can eventually meet, right? Now the y-intercept actually doesn't really matter. They can be different or the same. Right? Because it only matters when the slopes are different, right? If the slopes are different by any means, even if your y-intercept is the same, right, it will still intersect. Actually, if the slopes are different and y-intercept is the same, then a y-intercept is actually the point where it touches both lines. Right, so this is when we have one solution. Okay, how about parallel? Okay, as we know, parallel lines are the same, but the y-intercept must be different. Right, because as you can see here, right, even though those are the same slope, the intercept needs to be different. So no solution. Okay, no, what the? Right. And lastly, if they're the same line, right, that's when the slopes are the same and y-intercept is the same. Alright, so that's very important here. That's why we need to differentiate between the two, right? If the slopes are the same, we look at the y-intercept. If the y-intercept is different, then they're parallel. If the y-intercept is the same, then they're literally the same line. So infinite solutions. Okay, so as an exercise, given this equation here, right, let's write a linear equation for the same system where we have exactly one solution, no solution, and infinitely many. Right, so of course, we have to make sure that they have either different or same slopes and y-intercepts. So let's convert this into the slope-intercept form. Right, we can just add y to both sides to get y equals to 2x plus 4. Okay, of course, remember, that's our slope, right? And that's our y-intercept. So for it to be one solution, the slopes need to be different, right? But the y-intercept can be the same or different. So we can literally do something like, I don't know, 100x minus, sure, 752. Right? Yeah, eventually it will meet up at one point because the slopes are different. No solution, or none. Right? That's when the slopes has to be the same, so 2x. But the y-intercept needs to be different. So let's see, how about 4.1? Right, that's different enough. How about infinite? That's when both are the same. So in this case, 2x plus 4. Right? But we notice here how this is actually contradictory, right? Because what happened here, right? Those are two different equations. Why the infinite? Right? Because turns out that any multiple of this original equation will give you something infinite, right? If we just multiply everything by 3, right, that's still an infinite solution, right? Because they're essentially still the same line. The only difference is that I multiply everything by 3, right? But because I multiply 3 to this side and 3 to this side, effectively, this is still the exact same line. Right? So even if the slope and the intercept looks different, right? When you divide everything, because if we just divide everything by 3 again, we go back to this. Right? So it's always worth it to check. Okay, but with that being said, that's pretty much it for our first lesson here on linear systems. Right, there are actually 3 different methods to solve for systems of linear equations. The first one is graphing. Right? It may not be the fastest, right? But for our visual learners here, this is very useful. Okay, so with that being said, good luck practicing.